Applications. Early on, Schmidt et al. 1999, proposed 3 application domains that can benefit from context awareness: adaptive user interfaces that change according to the surrounding conditions, context-aware communication systems, and proactive application scheduling. Nowadays even more uses for the technology have been devised. This section discusses the use of the knowledge of context and the possible applications for the technologies that are used in context recognition. First, the characteristics of context-aware applications are described. Second, the major application fields are presented: home automation, work support systems for professional use, diary applications, mobile guides for free time use, healthcare, abnormality detection, ubiquitous learning and advertising. Examples and the technologies used in each group of applications are given. Finally, there is a discussion of the use of the context recognition technology as an enhancer of HCI and as a new input modality is covered. The need to determine the user's current context has emerged from the vision of ambient intelligence. Thus, the applications that use context information are mobile, ubiquitous services that offer the main benefits of context awareness, adaptation, personalization, and proactivity. Adaptation means that a system adjusts its behavior according to the current context. A mobile phone can, for example, switch to silent mode when the user is at a meeting. Personalization means that a system adjusts its behavior according to user preferences, habits, skills or tasks. For example, a shopping system can offer the user the products that are the most likely to be of interest. Proactivity means that the system can automatically act without user interaction and even anticipate future actions or contexts and act accordingly. Pitchler et al. 2004 Day and About have another way of describing context-aware applications. A system is context-aware if it uses context to provide relevant information and/or services to the user, where relevancy depends on the user's task. They also state that the applications have 3 different main categories for the context-aware features. They are presentation of information and services to a user, automatic execution of a service, and tagging of context to information for later retrieval. This division is widely used in the literature for describing the functionalities of context-aware applications. The authors have also made an exhaustive survey of the different definitions related to context awareness. Day and About, 2000b. We have discussed user-centric application design in our earlier work, Makonnen and Visa, 2007a. The idea was to make HCI more natural by considering the support of different human characteristics. Context awareness as such can enable this by increasing the amount of automation, memory support, and multimodality in the interaction. Context-aware applications do not always contain all these characteristics. In fact, the utilization of all the possibilities that the concept enables is usually very limited. Many technical issues are yet to be solved before there is widespread adoption of context awareness, but eventually it will become more prevalent as cheaper and more energy-efficient sensors come to market. Enabling devices to act smartly and independently is possibly the most obvious use for context awareness. When a device or any smart object knows what is happening in its surroundings, it can make life easier for its user. Schmidt describes how context awareness can enhance HCI. Basic ways to help system output include finding a suitable time for user interruption, reducing the need for interruptions, and adjusting system output to match context. Conversely, the input can be helped by reducing the need for user input and making it easier by limiting input space, and adapting the input system to the context. Schmidt, 2000. An example of this kind of concept is a portable consumer device. A working example of a context-aware mobile phone is Sensei, by Sawarek et al. This uses light, motion and microphone sensors for determining the user context. Context in this case is restricted to determining if the user is engaged in physical activity, the level of the background noise and if the user is talking. Calendar entries of meetings etc. are also used. The phone has 4 states, according to which the ring sound volume and the vibration alarm are modified. For example, if the user is in a do not disturb state, the phone sends an SMS to inform the caller. Sawarek et al., 2005. Another growing field is home automation, also known as the smart home, that increases automation of a normal home by using sensors and artificial intelligence. This attempts to make life easier for the residents, i.e. improve the usability of the home in various ways. This kind of system can control the heating or air conditioning, lights, curtains, audio and video devices, kitchen appliances, and even a sauna stove. Additionally, security-related systems, like fire alarms and surveillance, can be linked to the system. The system detects the context of the home and the residence by using sensors, and then adapts itself accordingly. The system can also anticipate the future actions of the residents. The technology will become increasingly popular in the future. Its major drawback, however, is that the connected devices must utilize a common standard. Moreover, context awareness can be thought of as an input modality when the system reacts to user actions on the basis of the context information. Salber et al. 2000, have addressed the topic. They state that multimodality refers to making explicit commands to a system and receiving output in multiple ways, whereas in context awareness the sensor input is done implicitly without explicit user commands. Fecki et al. 2004, have also studied the issue and present a vision of how context awareness can be used along with multimodality to ensure more efficient update of functionality to user interface for people with disabilities. An important point about context awareness is that it relates to many other technologies. The technology that enables us to recognize human physical activities and body movements, and thus enhances context recognition, can be used on its own to enhance HCI. Gesture recognition techniques often use data accelerometer sensors. Human hand gestures, for example, work as an effective input modality. Mantilla et al. 2000, have tested an accelerometer-based system for hand gesture recognition for the use of a mobile device. The system can recognize some of the most common gestures that are made when using a mobile phone. For example, this enables automatic call reception when the phone is moved to the ear. Bui and Wen, 2005, and Hernandez-Reballer et al. 2002, have studied sign language recognition using accelerometer sensors placed on a special glove. Earlier, Li and Xu, 1996, have used HUMS for recognition of gestures of a sign language alphabet. Pulveinainen, 2005, has studied hand gesture recognition from accelerometer signals using a hidden Markov model, HMM. Mantiervi et al. 2004, have designed a system for controlling a DVD player using hand gestures. The system also uses accelerometers and a hum. Darby et al. 2008, propose a hum-based real-time activity recognition system for gaming using Vicon, an optical motion capture system, as the input sensor. Healthcare systems that use context-aware computing are often used for ambulatory monitoring and remote-assisted rehabilitation. The health condition and physical activities of the patients can be monitored by using context recognition technology. By doing this, any alarming situations can be spotted. Preventive healthcare can also profit from the technology since tracking normal people's physical activities provides information on the amount of calories used and can act as a motivator for the user. Tintori and Favela, 2008, propose an activity-aware system for healthcare use. The system tracks the activities of hospital staff and assists their work by giving information on the status of the patient. The system also reports on other situations such as whether the patient has taken medication. Jovanov et al. 2005, introduce a wireless body area network, WBAN, based telemedicine system for ambulatory monitoring and remote-assisted rehabilitation. Many different sensors are used to monitor the patient's condition. Cheryl et al. 2005, have used activity recognition for monitoring motor activities of patients undergoing pulmonary rehabilitation. The authors state that the application would help clinicians and optimize the exercise capacity of patients. Another type of applications that relates to activity monitoring and healthcare is abnormality detection. By tracking any activity over a prolonged period, it is possible to detect behavioral patterns and gain a good idea of what is normal. Thus, abnormal or undesirable can be detected or even anticipated and thus prevented. Industrial applications have used such monitoring for a long time in applications such as monitoring processes in a chemical plant. Yen et al. 2008, have studied abnormality detection using data from body-worn sensors. They state that the approach can be applied in security monitoring for identifying terrorist activities, and also in healthcare to detect signs of serious illness. Diary applications exploit tagging of context information to different time-related events,